So in this video, we'll be talking about the instructions for your final Excel project. Basically, in this project, you're going to be summarizing data using Excel. So you've learned to do a lot of work this semester by hand. We've come back after the fact and learned how to calculate everything you did by hand using Excel. So now you're going to learn how to, and we'll talk about in this document here, how to actually summarize and analyze data using Excel. Your data set will be rather small that you're using, but you could take what you're going to learn in this exercise and make it bigger and analyze a lot more data than what I'm having you do here. So I will be sending you an Excel file that has, I think, like 290 lines worth of data. But I went in and I partitioned it into groups of 10 and put names in the first column. And so for this exercise, everyone will be analyzing different data, and you'll just pull out your 10. So the data in the Excel file is in alphabetical order for the students in the class. So you'll just go down, find your name, pull your 10 sets of data out, and that's what you're going to analyze. What you submit to me will need to be a Word document where you summarize your data in tables, text/sentences, or graphically. So those are kind of the three ways that you typically see data shown graphically, analyzed, summarized, and so we're going to have you use all three of those throughout this whole exercise. So another thing that you need to recognize is that if you create a table of something, you then don't need to talk about it in sentence form. If you create a graph of something, you don't then need to put it also in a table. So be very careful about redundancy, because you really don't need to, talk about the breakdown of gender in all three different methods. So we'll get into some examples of that later on in this video. I've given you some resources here, some websites. The first one, the OWL Purdue, really is related to how do you analyze, or how do you present data in table form per APA. So you can take a look at that. And then the second one there is some different ways to create or to represent data graphically. If you think back to our test 1 material, Excel, that whole first page of stuff talked about how to create pie charts and histograms and bar charts, etc. So between these two websites and the very first page of that document, you should have a good idea of how to graphically, the graphic part of this at least. Okay, so with regard to using the survey, hopefully you've watched the video where I showed the survey, talked about the parts of it, but remember the first 6 questions of that were demographic information. So 3 were quantitative, 3 were qualitative. We talked about them. For the purposes of this analysis, you're going to take 2 of those that are quantitative and summarize them, and 2 of those that are quantitative. So 2 quantitative, 2 qualitative that you're going to summarize. So 2 of them you just leave out. From a quantitative perspective, I will tell you that the 100% always way that you will summarize that, the quantitative data is with the mean and standard deviation. So I want to say 100% of the time when you've seen a string of data here, we've added it up, found a total, divided by the number, we found an average, and then many if not most times, we've also then found the standard deviation of that data. So quantitative data, the best way, the only way, the 100% way that you'll represent that is with the mean and standard deviation. You can add other methods, range, median, you can add some of those, but you must have the mean and standard deviation. So for questions 1 through 6, select 2 quantitative, 2 qualitative data, or two quantitative, 2 qualitative questions to summarize. The next 4 questions, 7, 8, 9, and 10, dealt with, this is probably not in the correct order, but like fitness level, diet, percent body fat, and then overall health. So of those 4 quantitative questions, because they all had quantitative parts to them, you will pick two of them, or excuse me, yeah, two of the four. I think I've got a typo there, but two of the four that you will actually need to summarize. I just completed doing the video for that, and I want to say on the video I may have said that you were going to use question number 10 based on overall health to do an independent t-test. But if you read step number 6 here, you're actually going to use the total coping competence scale, so questions 11 and 12, to do an independent t-test. So to reiterate, question number 10 on the survey dealt with overall health. I think on the video I talked about creating your groups and doing independent t-tests based on answers there. But we're going to actually do that for questions 11 and 12. So everybody in the class has 10 people that they are summarizing data for. You need to create 2 groups of people based on those demographic questions. So it could be 5 males and 5 females. It could be 5 lower class individuals, 5 upper class individuals, but pick something in the demographic questions that will allow you to create 2 groups so that you can then do an independent t-test between the groups. So I talk here about groups should be equal in number, for example, 5 males and 5 females, and there you're going to compute an independent t-test to see if there's a significant difference in total coping competence between your groups. So think about what we're saying here. What is your IV and what is your DV? Your IV is your grouping variable. So if you're using males versus female, your independent variable is gender. But for everybody, the DV, the thing that's being measured, is that total coping competence score. So using Excel, you're going to need to actually calculate total competence. And the way that you do that is for question number 11, you take all 10 questions for that. They were written as Q1 through Q10. For each person, add up all 10 of those scores for question number 11. For that same person, add up all 10 responses for question number 12. Again, Q1 through Q10. And then add those together. And that will give the total competence score for each of your 10 individuals. I went ahead and added a D here. The range of possible total competence scores is 20 to 80. And the lower the score, the better the coping competence someone has. The higher the score, the worse their coping competence is. So if you think about how we're creating this total competence, there's 10 questions for question number 11. There's 10 responses for question number 12. If everyone answered so that they had a 1 on each of those questions, 1 plus 1 plus 1 20 times gives us the low of a score of 20. If on all 10 of those responses they had a 4, 4 times 20 gives us that upper end of 80. So I'll be having some office hours where we talk about this, but that's how you do need to go in and create or calculate a total competence for each person. And then the last thing you're going to do for this is with regard to question number 13. And there were 11 feelings that were listed there. I mentioned a few of them in the video, but you're going to take 4 of those feelings and summarize them. What most students do is they pick they pick 4 that people respond very highly to. So if 8 of your 10 people said low self-esteem, or 6 of your people said frustrated, or those types of things, I think those are the things that you really want to summarize. And again, probably on this you're going to want to do something graphically. So there's some graphical ways that you can present that, and we'll be looking at those in just a moment. So all work should be completed in Excel and then brought into Word, and so you're just going to be submitting a Word document with your, or as the final project here. So the rest of this document talks a little bit about some good and bad examples of what other students have done that I've kind of brought into here to just kind of make some comments on. So this first one dealt with just reading the independent t-test output. Here they did a pretty good job. And notice, remember, t-stat is what you're looking at. It does give you a critical value, but really this p t less than or equal to lowercase t two-tailed is, you're comparing this number to alpha. So if this number is less than our default 0.05, then you would reject the null. So in this case, the person said, based on the data collected, there is a statistical difference in feelings about COVID. Clearly, this was a different DV, a different dependent variable between males and females. And then they went ahead and gave the means. The only thing that I might have done differently is put the higher score first. So the females with a score of 8.8, I probably would have given that first, and I would have given the male score second. Here is where the means came from. Notice here that they did not put, or they did actually put the standard deviation in here. And if you think back to our standard deviation formula, all you have to do to find standard deviation is look at the variance score and take the square root. So if you get a calculator out and put 12.7 in your calculator, take the square root of it, that would have been the 3.56, and then the square root of 5.2 should have given you the standard deviation of 2.28. Notice also here that question where you're using independent t-test, this is the only one where you're going to be using groups. Everything else, you're going to be talking about all 10 people together. So I'll say this again. The one question where you're doing an independent t-test, that's the only place that you're talking about different groups. You're not grouping anything other than that one question. So let's look at a few other types of things. In this case, and again, I'm not going to read this to you, the gray area, so that's sort of my commentary, so I would read that. But what someone did here is they graphed, if you will, fitness levels, and here were the possible fitness levels. So a low fitness level of 1 up to a high fitness level of 10. And what they put here on the vertical axis is the number of people. So the way that we would read this is that no one said that their fitness level was 1, 2, or 3, but 2 people said that they had a fitness level of 4. One person said they had respectively a fitness level of 5, and one person 6. And then 3 people said fitness level of 7, 3 people said fitness level of 8, and then 0 people said 9 or 10. So this is fine. And essentially, this is a histogram because frequency or number of people is on the vertical axis. But I want you to compare this to, and let me just add too, that fitness level was or is a numerical piece of data. And what did we say you will always need to do if you have a column of numerical data? In this case, this person had 10 fitness scores, mean and standard deviation, 100% of the time. So this is an okay graph of this, but it needed to be, and I'm not saying that they did or didn't do this, but it needed to, the mean and standard deviation of those 10 fitness scores should accompany a graph if you want to do it this way. But let's contrast that to a couple other things as we move down. And one of the things that we'll see as we move on is sometimes people take numerical data and they categorize it. So they put it in, they make it fitness level 1 to 3, fitness level 4 to 6, fitness level 7 to 9 or 7 to 10. And then they count frequencies in there. And you end up losing information if you do change quantitative data into qualitative data. So do not do that. Another point that I made is in previous semesters, people have put very few things into tables. So be sure throughout this whole document that you do put some information into table form. Okay, so here's some ways that kind of piggyback on number 2 up there, where or how you should not present data. So this may look very similar to graph number 2, but it's all in the details of what's on the horizontal and the vertical axis. So here, the person numbered each of their participants. And so they had a lot of data. So they had 18 people. And so here's person number 1, here's person number 2, here's person number 3, all the way down through person number 18. And so these are student numbers, and here are fitness levels on the vertical axis. And what I would say to you is that this doesn't give us any information because there's absolutely no meaning to the arbitrary student number someone was given. So if you read in here, I say person number 4 could as easily have been person number 8. So the ups and downs of this line don't mean anything because these numbers are randomly assigned. They're arbitrarily assigned to the person. So if you compare that to here, where these are fitness levels, and this is the number of people that said that, this particular graph does actually make sense. So hopefully it makes sense to you that putting student number or participant number on the horizontal axis doesn't mean anything. So here's another person who kind of did the same thing. This is person number 1, person number 2, person number 5, person number 9. And you can see the fluctuation in ages, but the ups and downs don't mean anything because these participant numbers have no meaning. Here's one that actually does make sense. And it does make sense because these are quarterback ratings across games in the NFL season. So Alex Smith, I think, is this yellow one. And so what the line means is these are his quarterback ratings throughout the season. So he kind of started high, and if you just drew a line through here, he sort of went down through the season. And then Patrick Mahomes, the darker line one, he had a great game in game number 4, it looks like, and then he kind of maintained, if you will, his performance level. And then I think this is, oh gosh, what's that guy's name? Fitzgerald, I don't know. But anyway, he's kind of roamed around the league. And so the point of this thing was that if you look at quarterback ratings between this Fitz guy, and they call him Fitzmagic here, he actually had some scores pretty close to Patrick Mahomes, who really is probably seen as a much higher caliber quarterback. But the difference here is that this is game 1, game 2. So this is time. And so over time, these graphs actually make sense. If these are participant numbers, it doesn't make sense and it has no meaning. Okay, so here is someone that, again, they were looking at feelings about COVID. And what they did was they used scores on the dependent variable. So in this case, it was feelings about COVID to actually make their groups. So this was all the people who had, quote unquote, low feelings about COVID. These were the feelings about COVID that had the higher feelings about COVID. And then they tried to do an independent t-test between them, which that makes no sense. So you cannot use your DV to make your groups. because your DV in this case is going to be uh, total coping competence. So you can't use highs and lows of those to create your groups. Use something categorical, gender. You can even use age, even though it's not categorical, because you can have your older 5 and your younger 5. But the key here is that you cannot use what you are measuring, the dependent variable, to form your groups. It makes no sense. All right. And this next one, this was similar to kind of your question number 13, where there was a list of things that, feelings or feelings about yourself or whatever. How do you want to be seen? That that the participants marked all that applied. And so what this person did, number one, is they divided these by gender. The only time you're dividing anything by groups is for your independent t-test. So one, this should have never had 2 columns, one for male and one for female. And then the other thing that's sort of bad about this is it doesn't really summarize anything. I mean, it gives the answers that everyone said, but if I wanted to say, well, X number of people out of my 10 wanted to be seen as physically strong, I still have to go in and say 1, 2, 3, 4, 5, 6. So 6 people did that. How many people wanted us to be seen as balanced? I still have to go in and count 1, 2, 3. So this provides the answers that the participants said, but it doesn't summarize all 10 together. So hopefully you'll see what's wrong kind of with this versus what I ask you to do for question number 13. So here's a better representation of that. I'd rather be seen as, mentally sharp. Okay, well, here's the categories, and then here's the number of people. So this is helpful. So this person probably had 12 people, and so 11 people said, I want to be seen as mentally sharp. They only had, looks like maybe 2 people that said thin, and, physically strong. They had, 5 people. So I would say this is a better graphic representation of how do you want to be seen, rather than dividing these into males versus females, and then not really ever giving the count. Okay. This one has no meaning because there's no labels on the axes. So I honestly can't tell you what this was even trying to demonstrate to me, because there were no labels on the axes. So just be sure that you do that. Okay, so here's an interesting one where someone was looking at the age of the participants, which is a quantitative variable. So here's an example where they took a quantitative variable and they turned it into a categorical variable. So here's the number of people who were 20. Here's the number of people that were 21. Here's the number of people that were 22. Here's the number of people that were 23. And then I suppose this they were not using students, or maybe they had a graduate student that was older. So number one, you don't want to do that. So do not take a quantitative variable, turn it into a qualitative variable by making categories. But then here's the other thing that they did. They never went back and averaged the true age of these people. They added 1 plus 2 plus 2 plus 4 plus 1 and divided by 5. Well, they had 10 people, so 1 plus 2 plus 2 plus 4 plus 1 is going to equal 10. And 10 divided by 5 is going to be 2. But it makes no sense. I mean, I can't even think about how you would interpret that, what they're saying. Really, I guess that 2 is the average number in a category, which again is not super meaningful. This was something that was separate, and they took their ethnicity and told me that 50% were Caucasian, 40% were Hispanic, 10% were American Indian, which is fine. But that same person took 5 plus 4 plus 1, and I guess tried to find a mean of that, which that mean still doesn't even make any sense. And then somehow they tried to take these percentages and they tried to find a mean and a standard deviation. So again, not what should have been done to analyze the data. Here is someone who, again, this was the feelings about COVID stuff. They had students versus non-students. So again, this is a little bit different than what you guys are doing, but they actually just read this output wrong. So here is their T observed minus 1.37. Here is their p-value, compare that to alpha. So this should have said there was no significant difference. So just be sure that you read your output correctly. In this instance, someone again took a quantitative variable, converted it into a qualitative or categorical variable, which A is wrong. But then, interestingly, one thing that they did is they didn't even make their categories the same width. So they had one person who had a GPA from 0 to a 2.0. And then they had two people who had a GPA of 2.01 to 2.99. So that's a full GPA. And then the next two, they divided each of these in half. So kind of a little bit of a double whammy there in that they shouldn't have created a categorical variable from a quantitative variable. And then you got to have equal widths, if you will. So think back to our class interval. We don't jump around in the size of the class interval from 2 to 5 to 10 and back to 5 and down to 2. So equal intervals is a must. Here's how someone, again, summarized age. They did it by gender, which is, you're not doing that. The only time you're grouping is using the independent t-test. And then, again, they just wrote the answers down of what people said, and they never provided an overall mean and standard deviation. So again, that would be something that would not be a good representation of the data. And then here's I guess they were trying to do a frequency distribution, but you really can't do this based on things that are not class intervals, because the way this question was set up is similar to your number 13, because there was a list of illnesses, and the people could select up to 3 that they did not want to happen to them. So they only had 10 people, yet there's 38 total answers to this. So maybe some people answered more than just 3, because this should have been 30. But it just doesn't make sense. Like, this doesn't make sense to say 100%, because each person could have up to 3 answers. So frequency distributions should only be done with numerical data, so like scores on a test or something like that, and not things where you're using words, or in this case, illnesses that you do not want to happen to you, because it doesn't actually make any sense. So hopefully this document has given you some insight into kind of some good ways to actually present data, summarize data, and then some ways that really have no meaning or are not the best ways to do that.